In this video, we're going to talk about reflections, and I want to go back to something that you have learned in college algebra. We talked about parabolas in college algebra and the leading coefficient determining whether the graph opens up or down. In this case, I have a parabola that opens up, so I know its leading coefficient is positive. This could be the graph of y equals x squared or 2x squared or 3x squared. I'm not sure what it is because I don't have numbers on my graph, but I do know that that leading coefficient is positive. Now here I've taken the equation of the graph in blue, made the leading coefficient negative, and then I see that I just have a reflection across the x-axis. We're going to have that same type of thing happening with the trig functions that we're looking at. Okay, we're going to look at the sine function on this graphing program. Notice that my sine function starts at the origin and it goes up. I can tell that because my y values are increasing, that the coefficient of the sine function is going to be positive. I have sine of 1x. Now, I don't necessarily have to start at the origin to have a sine function with a positive a value. As you can see on this blue graph, my graph does not necessarily have to start at the origin in order to have the coefficient to be positive. As long as your sine function is starting on the y-axis and increasing, you're going to have a positive leading coefficient. Here's the graph of y equals negative sine x. If I start on the y-axis and trace along my graph, you can see that I'm decreasing. That means my leading coefficient is going to be negative. And here you can see that my graph does not have to start at the origin. As long as I'm starting on the y-axis and then looking at my graph toward the right, the positive x-axis, and my graph is decreasing, then my leading coefficient is negative. And one thing I want to point out here is this is where we have a sine function. Cosine function is going to be a little bit different, and we will get to that a little bit later in the lesson. In example 5, we have the graph of y equals sine x, and we're asked to sketch the graph of y equals negative 2 sine x on the same coordinate grid. So there's actually two things happening with this equation. I not only have the leading coefficient being negative, but it's also negative 2. So I have to take into account that stretching of my graph. So my amplitude is going to be 2, so my maximum is going to be 2, my minimum is going to be negative 2. And here's a rough sketch of the graph of y equals negative 2x. Problem 6. Write the equation of each of the graphs below in the form y equals a sine x. First thing I want you to notice about this problem is that the form of this equation, a sine x, tells us that I don't have to worry about a vertical shift or a phase shift or a period changing. And I know that this is a sine function. The only thing that I am concerned about is that leading coefficient a. Okay, there are two things that we need to do. One of those things is finding the amplitude, or the absolute value of a. And a second thing I need to do is determining if that a value is positive or negative. And it doesn't really matter which order you do these in. On problem number 6, notice that if I'm starting at the origin and tracing my graph toward the right, then I am increasing. You can see where my blue line here that I'm tracing. is showing that my graph is going up. So I know that my leading coefficient is positive. I'm going to use my amplitude formula, and I'm going to find out that the amplitude is 4. So I know the equation of this line is y equals 4 sine x. On the next problem, I can see that if I start at the origin and trace my graph, I'm decreasing, so that tells me that my leading coefficient is negative. So I know I have the equation to be y equals negative something sine x, and I'm going to use my amplitude formula. The amplitude is 2, so the equation of this line is going to be y equals negative 2 sine x.